When you're ready.
Is everyone else ready?
Yeah. What's the name of it?
I'll just say.
Okay.
Let's start. So, my name is Manshu and my product is the Arduino automobile. The inspiration for this product came this summer. I went to San Francisco and I went to the Computer History Museum and I saw a version of the Google car. And I was really entranced by it. I couldn't tear my eyes off the sensors, casing the room, the environment. They had an exhibit with the code on it that showed all the heuristics for the search algorithms. And I really liked the concept. So a few months later, when we're told to make a project out of Arduino, that's the first thing that popped into my mind. Let's make a car that detects collisions and also follows a path. So that's what my project is. Now, there were some difficulties, and in the end, unfortunately, this product does not work as it was intended to be. But what it's supposed to do is follow a path using line following sensors. I set up a course at home, which I did not bring in because it didn't follow the course correctly. But basically, I made a whiteboard and put some black tape down, and these line following sensors would follow the line. And then I put some obstacles on the course, like a pencil sharpener or a notebook, and this collision detection sensor was meant to walk away from the collision, move the robot back a little, and then turn it around and follow the line again. So the problems that I faced in this project were mainly constraints of the Arduino, but I'll get into that later. First, let's talk about the process. So to begin, I had to find the parts for this project. And the advantage I had was that we had most of the parts already. The disadvantage was I had to go into the abyss, or the robotics. It was really crowded, there's a lot of the parts there that I just couldn't find. So I did use a lot of substitutes in the project that may have hindered the final product. But in the end, this is mainly what you would see in a car like this. There's stilts holding up this sensor above with the breadboard above the Arduino circuit. The battery pack is inside the chassis, and there's motors on each wheel that I can control via the wires that I've attached to the Arduino. There's also a motor shield on top of the Arduino that's connected to the line following sensor. So it's a pretty common setup for projects, but you'll never actually see an Arduino with line following sensor and collision detection attached on top, mainly because it doesn't work. The Arduino isn't powerful enough to host such a capable pair of sensors. So next part of my project, after figuring it out, I had to do a four-wheel drive car. I wired this together with soldering. As people have mentioned, soldering is the process by which we wire the wires together using the hot metal. And I also had plenty of problems here. I burned myself a couple of times, burned some of the parts. So it didn't work out flawlessly, but in the end I did wire all the parts together using the knowledge that we went through in OPSET class. And then finally I used this book here, and I used it to learn how to wire the sensors. I didn't know how any of these sensors work, so I used the book to put the sensors into the car. Finally, coding. We've learned how to code sensors, and we've learned how to use libraries online to find the correct code. So that's mainly what I used. I used the library online to find the ultrasonic sensor and the code for the line following sensor. And I tried to combine that. What we have in Arduino is a loop function. You basically go through the function and loops the function over and over, implementing it over and over inside the Arduino. Now, my car here has a third function called the siren on top that I use to demonstrate our knowledge of lights and sounds. I use the tone library, and what I do is I start off in the code by presenting one light goes on, and one tone comes on the siren. And then it goes through the line following sensor to make sure the car is still online, and then it makes sure that the collision detection sensor doesn't find any objects. Then it goes to the other tone of the siren and it repeats the whole process over again. The problem with this is that it consumes too much of the memory, so when this line following sensor finds the line, its task is done. Then it goes to the collision detection sensor, and that consumes so much of the memory that the product wasn't able to work perfectly. The collision detection sensor basically takes over the whole robot and it stops following the line altogether. And also, the motor shield got cooked a little when it was handling all the memory, so some of the wheels don't turn all the way or the right way when they're supposed to. And finally, what I've learned from this project. So this project, it taught me a lot of things about Arduinos and circuitry. Its applications are far beyond a computer science course. It's really a proof of concept of how we use circuitry to connect lights and sensors and how we use it to power circuits. Also, there's the libraries. I learned how to utilize the resources that I've been given, such as the Arduino libraries, as well as the libraries for the sensors and the circuits. I use the tone library to find the sounds, and I also use the light library to find the different shades of light that I could do. And finally, as with any computer science project, I developed problem-solving analytical skills. But the big lesson that I learned was to plan ahead. It's at the end of this project, I did some research and I found out that these two sensors, they each consume, when optimized perfectly, they consume too much of the Arduino's memory to actually run both at the same time. I tried stripping down my code. The way this works is the two outside sensors follow the white of the whiteboard, and the middle sensor follows the black of the tape. I tried stripping down the code so I'd only need one sensor. I tried stripping down this code so it wouldn't adjust so much for every little object in the middle. But the point is that when the Arduino goes through the loop function, this one ends up taking over the whole robot. And if I planned for that earlier, I might have been able to solve some of the major problems of this project. But in the end, it was a great learning experience, and I thank you for your time. Do you have any questions?
So a major portion of your problems came with kind of basically memory and not being able to contain as much of it as you like. If you were to reattempt this in the future, would you be able to attempt it with 2 or 3 Arduinos each running a particular part of the robot? For one would be the line tracker, the other would be what?
Yeah, that's exactly the idea. So one Arduino, so it goes back to the one Arduino loops through the same function over and over, and I can't make it call the siren function just running in the background while these do their thing. So if I had 2 or 3 Arduinos running each of the sensors on their own and one Arduino running the light, then that would solve the problem. But with the resources that I was given for this project, it was it consumed too much of the memory at once, and that's just not good.
What was the name of the robot?
The Arduino automobile.
How did the collision sensor, it looks to me like it's pointed to see things really far away. Did it
So the way I
also
coded
pick
this
up?
is,
Yeah.
the way it works is it sends out sound waves from one end and it receives sound waves from the other. It times, my code times the amount of time it takes for the sound waves in microseconds and converts that to inches using an algorithm I found in the library. And then I detect whether if an object is 8 inches away, then it's too close for comfort. So I make the robot move back a little, turn right, and move around the object until it doesn't detect any object within 8 inches. Only problem with that is, as I mentioned earlier, it gets stuck in that loop where it keeps finding objects within 8 inches, and then this basically runs the whole thing.
Okay, thank you, Manshu.